Hey gang, so this is page 12. So this is the page that you'll really like. All right, so now that we know how to do integration, we know how to do the trapezoid rule, it's time to just use our calculator on this. So if I give you a simple problem and just say integrate from 0 to 1 the square root of 1 minus x squared dx, all we're going to do, I'm trying to find a spot where my calculator will show me move that. All right, I'm going to turn it on. Here we go. Y equals, I'm going to clear it out, and I'm going to say whatever's the function right here, the square root of, so second square root, 1 minus x squared. I'm going to graph it. I'm going to zoom in. I can't really see that very well. There we go. Now I want to go from 0 to 1. So I'm going to go second calculate. Number 7, find the limit. Or find the limit. Oh my goodness, y'all. Integration. Lower limit. Lower boundary is 0. I can't get my words right tonight. Upper boundary is 1. It shows, and here it is. So I'm just going to simply say it's approximately, okay, I got to zoom in, 0.7854. 0.7584. If you want to do those 3 sig figs, you would say it's approximately 0.758. All right, I'm going to do the next one. This one is, we're going to do second square root of x. We're going to graph it. And we're going from 0 to 9. So I'm going to zoom 6 so that I can see more of it. I'm going to do second calculate. The sum of the lower boundary is 0 to 9. Let's find the area under the curve right there. And it is approximately 18.0. All right. I know you're already like, oh my goodness, this is so much easier than what she was doing earlier. Okay. Find the area of the region bounded by the graph of this, the x-axis, and the lines x equals -8 and x equals 4. So that means we're taking the integral from -8 to 4 of x squared plus 17x plus 106 over 2 times x plus 11 dx. So I'm going to put that into my calculator. Y equals, I'm going to clear that out, alpha y equals, and I'm going to do x squared plus 17x plus 106 over 2 parentheses x plus 11 parentheses. I'm going to graph it. There it is. And I need to go from -8 to 4. So I'm going to second calculate the integral from -8. Upper boundary is 4. There it goes. Isn't that pretty? And there it is. So let me put is approximately, let's see, 56.9. I'm just going to go ahead and, not 9, 2. The 8 rounds it up to a 2. All right, there we go. All right, find the area of the region bounded by the graph, blah, blah, blah. I'm going to let you do that on, oh, you know what? I did not do that one. Okay, so let me go ahead and do it. I'm going to go here, clear that out. Alpha y equals, here we go. X, house top 8 plus x over x to the 3rd plus x squared, graph it. That's pretty. And we are going from -95 to 105. I'm not. Okay, so the error was on my part. This should not have been a negative. So let me make that a little zoomed in a little better. So I'm going to go back to my calculator. Okay, so here's my graph. But remember, if you're going to go from 95 to 100, you need to be able to see it here. So I'm going to go to Window. I'm going to set this from a positive 90 to like, I don't know, 110, just a little bit more above and beyond. But I also need to set my vertical window as well. So second table. And so I'm going to go to where x is 95. Let's see when we do that what the value is. So 7 point, oh my goodness, times, so that's like 7.66 times 10 to the 9th power. So what I'm going to do is go to my window. I think I can actually put that in. 7.66 times 10 to the 9th power. And then this one, I'm going to go second table. I need to go over to like 110. Let's see what it is there. 1.6 times 10 to the 10th power. So window up here, 1.6 times 10 to the 10th. I can't remember what it was. I think it was the 10th power. So now let's graph it. And I can see it there. Okay. So I'm going to do second calculate the integral from 95 to 105. There it is. It's going to give me my estimate. And the estimate is 9.9839 times 10 to the 10th power. Oh, I didn't rewrite this one. Okay, so let me rewrite it. We're going from 95 to 105. X to the 8th plus x over x to the 3rd plus x squared dx. Be sure you get the dx. It is approximate. Okay, I'm going to put this over here so I can read it. 9.98 times 10 to the 10th power. There we go. I'll put that there so you can see it. There you go. Okay, so that gets those. So now we've got an application one. So let's see if we can get this one. Okay, so a model car is traveling on a straight road. Its velocity t seconds after the start of the movement is given by a velocity equation there. The car stops 5 seconds after the start of the movement. How far is the car from the starting point when it stops? So you already know from physics, right? Your physics studies, that the area below the velocity time graph gives the distance traveled. I'm hoping you know that. So in other words, if I had something like, I'm going to say like this right here, if I find the area under here, then I know that that is the distance traveled. The area under a curve is the distance traveled. That's why you guys, every time we started doing this, everybody's like, I feel like I'm in physics class. Okay, so what's our integral going to be? We're going from 0 to what? Straight road, velocity t seconds after it starts the movement. The car stops 5 seconds afterwards. So we're going to stop 5 seconds afterwards. So we're going to do t, parentheses 5 minus t, all over 3, dx. We want to know, what is that? What's the area under the curve? Okay, well, calculator, clear it out. Now, because we've been messing with the window, I'm going to do Windows. Actually, no, I'm going to do Zoom 6. And that takes everything back to normal. So now when I go here and I do alpha y equals, and I do x parenthesis 5 minus x parenthesis over 3, and I graph it, I'm going to do second calculate. I'm going to do number 7. I'm going to go from 0 to 5. And there it is. So it's approximately 6.94. 6.94. There's my velocity, meters. Because our question was how far is the car from the starting point? So you want to be sure and say we are 6.94 meters. All right. Hopefully you're enjoying that. You're like, oh, this is not too bad. Okay. Let me go here. In economics, the Lorenz curve is a graphical illustration of wealth. The lower curve of the diagram below is a typical Lorenz curve. Here, let me get this a little bit closer to me so I can read this. All right. A related concept is the Genie index, which is a measurement of inequality. The Genie index is calculated as the ratio of the area of the upper region, which is the red. I think mine says red. Oh, no, I changed it to upper. Upper region on the diagram to the sum of the area of the upper and lower regions. Okay, so here's the question on this one. Find the Genie index. If the equation of the Lorenz curve is all that, where x% is the cumulative share of people and y% is the cumulative share of the income earned. I'm going to give you a second to think about this one. This is going to be a check for understanding. Okay, this is going to be a check for understanding, meaning I'm not going to finish this one. You are going to finish it, and you're going to go over to Canvas, and you're going to put your answers on this one on Canvas. I'm going to ask you some questions about this one. I am going to help get you started on this one, though, because there's a lot of information going on. What you're trying to look at, let's just look at what they said. So this is just a geographical representation. The problem is here, you can't really see what's going on. So what they're saying is you've got this straight line, and this coming down is information, and then you've got this curve right here, and coming down is another representation. And what you are looking for, if you could have seen, if this was color, the way it's highlighted and everything, you want to know that highlighted part right there. Oh, that looks really nice now. That's what you're trying to find. Okay? Now, find the Genie index of the equation of the Lorenz curve, which is 75, blah, 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 of this, where x is the percent of the community. So you're trying to find this right here. A related concept is that the Genie index, which is a measure of inequality, excuse me, where am I looking? Here we go. The lower curve. Thank you. The lower curve on the diagram below is a typical Lorenz curve. Okay, this is a typical one. So what we need to do, what you're going to do, is you want to figure out the upper, right? What's the upper curve? And we are going, if you look from 0, that's, I believe that's oh, that's really hard to see. That's 100%. That's 100 right there. So that means what we are doing is we are going from 0 to 100 of f of x dx. And you're like, well, which one's f of x? That's the top one. This is f of x. Okay. I'm going to call this one down here. I think I called it y when I worked it. And so let's just talk about to find this right here. What you need to do, think about these two functions, and maybe, looking for my highlighter, maybe if you looked at it this way, in order to find just the yellow, if I took the big triangle, and which is f of the area under f of x, if I took all of this and subtracted off the pink, the only thing left would be the yellow. So I'm going to set up my equation. I've got f of x. I'm going to subtract off y, and what's left is going to be the yellow. So you're going to do that. You know y. I give it to you right there. Oh, but you don't know f of x. You know what? You got some mad algebra skills. It's nothing more than a straight line. I bet you can figure out the equation of that line. All right, good luck on that check for understanding.